Consider this: you have a pizza with you and some hungry buddies. But you want to know first whether you can split the pizza evenly among your buddies. So instead of taking out your calculator, you could use these simple shortcuts to do the math in your head. And these shortcuts come in the name of divisibility rules or divisibility tests. So let's get started. Firstly, every number is divisible by 1. Any number divided by 1 will give back the number itself as a result, irrespective of how large the number is. A number is divisible by 2 if its last digit is a multiple of 2. That is to say, simply, that if we take the number and divide it by 2, we get back a whole number, or the multiplier. In a straightforward way, a number is divisible by 2 if it's an even number, that is, ends with 0, 2, 4, 6 or 8. A number is divisible by 3 if the sum of its digits is divisible by 3. 522 is divisible by 3 because the sum of its digits is 9, which can be divided by 3 to give 3. So, it passes the divisibility test for 3. A number is divisible by 4 if its last two digits are divisible by 4. The last two digits of 3,316 are divisible by 4, so it passes the divisibility test for 4. A number is divisible by 5 if its last digit is a 5 or a 0. It's that simple. Both 610 and 3315 fulfill this condition. A number is divisible by 6 if it's divisible by both 2 and 3. The number 255 is divisible by 3, as the sum of its digits are divisible by 3, but is not an even number. So it's not divisible by 6. The number 4608 is an even number, and the sum of its digits, 18, is divisible by 3. So it is divisible by 6. We'll shortly address the divisibility rule for 7 as it requires a few more procedures, but very easy. The divisibility rule for 8 will take longer to determine. To know whether a number is divisible by 8, you'll need to determine if its last three digits are divisible by 8. Consider a number 24344. Its last digits are 344. 344 is divisible by 8, giving a whole number of 43. A number is divisible by 9 if the sum of its digits is divisible by 9. Example: the digits to the number 1764 have a total value of 18 when added together. 18 is divisible by 9, therefore the number is divisible by 9. A number is divisible by 10 if its last digit is a 0. It's that simple. 1590 is divisible by 10. Let's skip the divisibility test for 11 for a little later. A number is divisible by 12 if it is both divisible by 3 and 4. We'll have an example with the number 7512. We'll start off with the divisibility test for 3. Adding up all digits gives us 15. 15 is divisible by 3, so the number passes the divisibility test for 3. The number also passes the divisibility test for 4, as 12, which is the last two digits, is divisible by 4. Let's address the divisibility rule for 7. Let's take a number, 6895. To know whether the number is divisible by 7, we shall first remove the last digit, which is 5, and multiply it with 2. We get 10. Then we shall take the remainder of the number, which is 689, and subtract the 10 from it. We get 679. Now, we could try to divide 679 by 7. The aim of this video, however, is to do the divisibility test from the head. Since we can't divide 679 easily by head, we shall repeat the whole process again. So remove the last digit, which is 9, and multiply it with 2. We get 18. After taking away the 9, we were left with 67. So, we'll subtract the 18 from 67 and obtain the value 49. Now, we can easily tell that 49 is divisible by 7. Since 49 is divisible by 7, the original number 6895 must also be divisible by 7. Let's address a longer number, 18046. First, we shall drop the number 6 and remain with 1804. Then, we shall double the 6 that we had dropped, giving us a 12. Then we shall take the 1804 and subtract the 12, to get 1792. Our aim is to get a 2-digit number, so we shall repeat the process at least 2 more times. We shall drop the 2 and double it. Then subtract the 4 from 179. We remain with 175. Finally, we drop the 5 and double it, to get 10. We shall then subtract the 10 from 17. We remain with a 7. Since the 7 is divisible by 7, then the original number, which is 18046, is also divisible by 7. Now you know the divisibility test for 7. Let's address the divisibility rule for 11. We shall use the number 9581 for our first example. So, we'll begin from the left, assigning plus and minus operator signs in alternating fashion. Then we shall do the operation from the left and towards the right strictly. We shall not give first priority to the addition operators. First off, 9 minus 5 will give us 4. Then 4 plus 8 gives us 12. And 12 minus 1 results to 11. Since the final result is 11 and a multiple of 11, then the original number, which is 9581, is divisible by 11. Note that 0 is also a multiple of 11. So, a resulting value of 0 means the number is divisible by 11. The next example is with a longer number, 98517. First, we assign operators in alternating fashion. Always begin with the plus. So, we'll subtract 8 from 9. Then add the 1 to the 5. And subtract the 1. Then add 7 to the 5. And we get a final result of 12. Now, 12 is not a multiple of 11. So the original number, 98517, is not divisible by 11. Now, the ball is on your court. Without use of a calculator, determine whether the number 918071 is divisible by 11. Finally, let's move on to the divisibility test for 13. The procedure is quite reminiscent of that for the number 7, but a little different. So, we shall use the number 2795 as an example. We'll remove the last digit and multiply it with 4. In our case, we get 20. Then, we shall add it to the remaining number, 279, to get a total of 299. Then, we shall remove the 9, then multiply it by 4, with the result being 36. We'll add the 29 to the 36 and get the result 65. 65 is divisible by 13. So the number 2795 is divisible by 13. Click the like button if you enjoyed the video and don't forget to subscribe if you haven't done so.